Who is going to be the mute, to do the mute and unmute?
I'll do that. I'll do the mute and unmute.
Then the recording.
Yeah, I also do the recording.
Okay. Monitoring the chat.
And then I also monitor the chat. That's fine.
I can see a list of people. I don't know where did I press.
Yeah, if you are not requested to talk, I think you mute yourself so that so that we don't get the feedback from your side. Is Luca there? Okay, let us try to mute. Let's try to mute. Ideally, whenever you connect, you mute yourself until when you are requested to speak, okay? Yeah. Then the other thing is, please register your presence. Let us know what we can see here are the connections, some of which are not named. You see GX5, GUX5, so you don't know who is behind this connection or how many people they are. So we request you to actually register, help us, because this is very important for our tracking and our M&E, for us to know who are the people on this call. Please use the chat, register, tell us where you are connecting from and who are the people on that connection. If it is one person, you still indicate your names. If it is a couple of you, you also indicate the names of the other people who are attending the call at the same connection with you. So we want to know who are the people who have been on this call. Should you have any question, please use the chat. Just make sure you go to the chat. As you use the chat to register your presence, you can use the same chat to register any communication, any question that you may want to pass on. And there will be somebody monitoring the questions and the interactions on the chat who will at the appropriate time read out these questions for the appropriate people to answer. So with those ground housekeeping rules,
so Luca is joining in as in a short while. There were some technical challenges. Yeah.
Okay, but he's trying to connect. Eh?
Yeah.
Okay. Okay. So so with those housekeeping rules, let us make sure that there is no interruption. If you connect and you don't mute, anything that comes from your end interrupts the session. We should only hear the person who holds the floor, so that there's only one communication at a given time. So whoever you are not asked to speak, please keep yourself on mute. Okay? Okay, so I take the pleasure to welcome all of us. We already have a couple of you people who are connected. We have about 38 connections, but we want to know how many people and who are the people behind those 38 connections. That's very important. Please help us and go to the chat and register. Tell us where you're connecting from. Who are you behind that call? I mean that connection. If you are more than one, register everybody at your station. That will be very helpful. And track as the discussion goes on. If you have anything you want to ask, please put in the question right away. Somebody is connecting. So, I mean, somebody is monitoring the chat. So we'll be able to read the questions at the appropriate time. So I welcome all of you. I'm seeing Julia from Zambia, Jalia from Zambia, and the rest of the people. I'm seeing so many people from many different places. Thank you for connecting. And I wouldn't want to take much more time. Today, we are continuing with our waste management sessions. And unlike the last few sessions, this one is going to be a case study of some best practice or some implementation experience from one of the countries that have been undertaking some innovative way to manage their waste from viral load tests, viral load and EID testing with some practical innovations. So I think it will be quite an eye-opener. So let us be keen to listen to these experiences, and then we will react. So I hope our presenter, Laka, I see you on. That is good. We are delighted today to have Luca Fontana, who is a toxicologist with vast experience in waste management. So we'll be sharing some experience from Mozambique, which she's been involved in undertaking. So today we are really very delighted to have an expert, and not only an expert, but with implementation experience, coming in to share some of the best practices that have been implemented innovatively and they have worked, and how we can also learn a lesson and pick a leaf to see that we come up with operable solutions to the challenge. So I forward the floor now to Anafi. Then Anafi, you can quickly set in Luca to start the session.
Thank you, Charles, and thank you, everyone, and apologies for the delay. Whilst Luca is setting up, Luca, kindly share your screen. I would like to quickly hand over to David to introduce Luca.
Thanks, Anafi. Can everybody hear me?
Yes, we can hear you.
Okay, great.
Yeah.
Well, welcome to, I think, our fourth training session on viral load waste management. I just want to very quickly introduce where we're at and how we got here, and then I'll introduce Luca. We have been now through this is our fourth training session. We started off talking in general about healthcare waste and what it means and how to
David, you muted yourself.
David, you are mute.
Yeah.
No, I don't think so. No.
Yeah. Okay. Now it's okay.
Okay. I don't know. Something's going on, I guess. I didn't touch anything. So anyway, we've discussed healthcare waste in general. We've talked about the WHO guidance regarding healthcare waste and specifically chemical waste. Last month we had Kat Sleeman from our group here at ILB regarding a tool, basically a draft tool to determine gaps and analyze your gaps for waste management. And we'll be talking about that more, but this will be our first presentation from someone in the field, someone with field experience in a country that has dealt with this issue of viral load waste management and how to deal with it. We first met with Luca about 1 year ago now. I think it was June 2018 when we were introduced to Luca. And Luca, we got on the phone with Luca and discussed what his experience was. And it turns out that Luca had a very, very innovative solution, or a couple of good ideas and solutions possibly for looking and dealing with waste management. And so that's what we're going to talk about today. Just a little bit about Luca. Currently, Luca is an environmental toxicologist and epidemiologist, and he specializes in hazardous waste management. He works for Médecins Sans Frontières, and he is currently based, I think, in the DRC, dealing with the Ebola outbreak that's ongoing right now. Ebola hemorrhagic fever is something that me and Luca have in common, and I need to talk to him more about Ebola, because that's the way I started off in this business. He has experience in dealing with the viral load waste and experience with the Gene Expert cartridge waste management. So we hope that you all welcome Luca, and hopefully you will have some very good questions at the end of his session. So Luca, hopefully you're ready.
Yes, I am.
Thank you very much, Luca. Take it away.
Thanks a lot, David. Nafi, thanks, and nice to meet you all. So today I'm here just to briefly describe you my field experience in viral load waste management. It's something I did in Mozambique back in 2016-17, but that has been replicated somewhere else like Malawi and Zimbabwe. Briefly, this is the presentation index. We will go through background and different steps I went through in my field experience, the different outcome we had. Absorption, it's something I will introduce to you, maybe a new approach you will be interested in, a resume of the outcome we had, and a toolbox that should allow you to go back home with some tools and idea to start from. So, as we know, there are a million people today receiving IRVT in the world, and we know that one of the most efficient way to monitor the efficiency of the treatment is viral load testing. That is recognized as the only way to evaluate correctly people living with HIV. The point is that, as we know, this viral loads platform are producing waste. Back in 2015, we realized that in 4 countries where MSF, Doctors Without Borders, was running HIV program, with all the machine we had, we were producing something like 16,000 liters of viral load waste, which was quite a lot. And we had no idea about the kind of waste we were producing, how to deal with it, and what to do with it. So the first step was to talk with the manufacturer, and here you can see the kind of consideration were stated by the manufacturer itself. So dispose the chemical waste in compliance with correspondent local law and regulation, or that they were recommended to contact either the authority in charge or appropriate disposal company, which will advise you on how to dispose this type of waste. But what happens if there is no local laws or a national regulation, or what to do if there is no authority in charge or private company or public company responsible to deal with this kind of waste? So the second step was to better understand which kind of waste we were talking about. Okay. Yeah, it's okay. So we know that some of the platform are using guanidine thiosanate in their reagent. Not all of them, but many of them. But despite the fact we know the composition of the reagent, we didn't know what was the weight itself. So the next step for us was to ask a South African lab to do an analysis to better identify the component of the waste. And something we were not considering, but we had 10,000 ppm in our waste. Everybody knows cyanide is dangerous. It's acute toxicity class 4, which means it's harmful if swallowed, harmful if inhaled. It's aquatic chronic toxicity class 3, and it's harmful for aquatic life with long-lasting effect. Knowing the concentration of cyanide in viral load waste, we tried to do an estimation of the lethal dose 50% for oral for injection for a man of 70 kg, and then you can see it's the LD50 is comparable with some of the most known toxic product like mercury, arsenic, or cyanide itself, or DDT as well. The next step, knowing now that we knew that how dangerous was the waste we were producing, we start storing in plastic tanks. That clearly was not a long-term solution. Otherwise, we would find ourselves overwhelmed by tanks. Doing the same, on the same line, we decided to define a standard operation procedure to protect our staff and the environment. So we draft which kind of personal protective equipment were needed to handle this kind of waste, like respirator with cartridge ABAC, disposal metal gloves, or face shield. And we try to identify the most dangerous point for this kind of waste, like never mix with other substance because it might produce hydrogen cyanide, well known like prussic acid. On top of that, we try to define measure for cleaning, collecting case of splash or overflowing. Just remember that we're talking about a liquid waste and in big volume. Liquid, and remember, around 16,000 liters per year, which means it's not easy to handle, and splash and overflowing can easily happen. That's why we decide to draft this SOP. So how can we handle splash or overflowing? Here you can say it's absorbed with the liquid binding material like absorbent pads, rinse with water and let dry. Don't use chemical product to clean it up. Why? Remember, never mix with other substance because there is risk of production of hydrogen cyanide. Dispose of contaminated material as waste according to the SOP below that we will see together now, and ensure adequate ventilation. Another important aspect for us to reduce the risk for staff was to define the post-exposition prophylaxis. According to the exposure way, means inhalation, skin contact, eye contact, ingestion. We draft the symptom. We didn't draft. Sorry, all this information were provided by the safety data sheet coming with the product itself. But we thought it was important to make staff aware of all this procedure before handling this kind of waste. Then once we manage to protect our staff and we start storing all this waste, we start looking into possible solution on how to dispose the final disposal. The first step was to assess the national regulation, the local law, if there was something available. And actually, in Mozambique, there were 3 different regulations. One talking about waste management regulation, hazardous waste regulation, and healthcare waste management regulation. Despite the presence of these 3 different regulations, none of those were talking specifically about liquid hazardous waste, and we're not providing any kind of technical SOP or technical directive on how to dispose properly this kind of waste. What we know and what we knew there is that 99% of hazardous waste should be destroyed through medium and high temperature incinerators, expired drugs included. High temperature incinerators means a temperature above 1100 or 1200 Celsius degree and 2 second retention times, a temperature that we can find in a cement factory kiln, or medium temperature above 850 Celsius degree and 2 second retention time, a temperature that can be reached in a specific high-tech incinerators. A limit is that only 1% of hazardous waste can be disposed in this way, which means that we need 99% of other medical or other non-hazardous waste. Or another option is to return to manufacturer or donors. So starting from the theory, we start to assessing the situation in Mozambique. More specifically, it was in Maputo, and we found some high-tech incinerators. Here we can see what's the advantage, what's the asset of this kind of approach. An incinerator, it's an internal management. That means that an hospital with a lab can directly manage all the waste produced. It's replicable because an incinerator can be purchased and installed everywhere, at least in big hospital only, because we still need the 99% of non-hazardous waste to dispose with the 1% of hazardous waste. The waste can be disposed on a daily basis, which means a limited waste storage. So less risk. This kind of incinerator, what they need here is, as we said, medium, at least medium temperature, means above 80 and 50 Celsius degree, 2 second retention time. That's because the thermal decomposition should allow, this high temperature should allow the total thermal decomposition or the dangerous product. Now, what are the constraints of an incinerator? I mean, it's true that there were several machines installed all over the country, but the maintenance were not properly done, and an automatic loading was needed. That's because without the automatic loading, every time we open the door to load the waste, the temperature will drastically drop. So in order to avoid this kind of temperature dropping, we need an automatic loading. It allows only small quantity of hazardous waste per cycle, 1%. This one you can see in the picture. It's allowed to dispose 15 kg every 15 minutes. It's 60 kg per hour, and we can burn only 1% of hazardous waste, which means 6 kg every hour. It demands a lot of maintenance, spare part, and skilled and trained operator, and it's very expensive. This one you're seeing in the picture can consume around 20 liters of fuel per hour, which is quite a lot. A second option we assessed in Mozambique was a cement factory. Nearby Maputo, there was a cement factory. It was working, it was available. We managed to discuss the open discussion with them. And it was well functioning. They had regular follow-up, SOP, they were monitoring the temperature, everything. It's allowed to dispose big quantity of hazardous waste per cycle. 1%, this specific cement factory was producing 200 tons per hour. So we can easily understand that 1% of 200 tons per hour, it's a lot of waste we can dispose in a shot. It means that one cement factory could easily cover the needs of a whole country. And it was quite cheap. We were paying around $1 per kg. And let's remember that the incinerator alone was 20 liters of fuel per hour. The main constraint, talking about cement factory, the main constraint we face is that biological risk was not accepted at all. The waste need to be stored for a long time because the cement factory that decide when to proceed to disposal, because they have to stop their production for a while, and that means that the schedule need to be decided by them. And many actors need to be agreed. Many actors needed to find agreement among them. Like, for instance, the cement factory, you need to decide when, which procedure, which kind of packaging, time, when. The Ministry of Health, because they need to provide validation, they need to provide an inspector in order to certify that extraction happened in a proper way. The Ministry of Environment, because they have to validate the transport, the packaging, and the cement factory itself. And then a transport company, because somehow we had to move our waste from our warehouse to the cement factory itself. So we had to find a transport company who had all the license, SOP, trained staff, authorization, everything. So as you can see, there are many people that need to agree about something and need to sit around the table. A third option we decided to assess was the waste exportation. That was possible thanks to the Besson Convention on the control of transboundary movement of hazardous waste and their disposal. Fortunately, both Mozambique and South Africa ratified the Besson Convention. It means that that means that it was possible to move the waste, to export the waste from Mozambique to South Africa. We identified a transport company and a disposal company. The main constraint is that it was a really long process. It took 6 months to export a bit more than 1,000 kg, and it means a long waste storage. It was quite expensive, around almost $7 per kg compared to $1 per kg for the cement factory. It's limited to country ratified Besson Convention, and the transport company must be authorized in both countries. It means that there are a lot of boxes that need to be ticked before going for this option. Here, it's a short resume of the 3 different options, the 3 different technical solutions we assessed in Mozambique. So incinerators, cement factory, and transportation. Incinerator, the main advantage is that it's replicable in every big hospital and allow limited waste or limited time of waste storage. Constraint is that only specific incinerator, high-tech, that allowed only a small quantity to be disposed at the times, and it's a quite expensive solution. A cement factory, it's a step solution and allowed big quantity in a while. Well, as we said, one cement factory could cover the needs of a whole country. The problem is that it's not replicable everywhere, and not all the country has its own cement factory, and it demands a long waste storage. Exportation, clearly, it's an external management. It means it's enough to pay a company, if one available, and they will take care of it. But it's a long process, it's expensive, and it's not replicable everywhere. So only for the country ratified the Besson Convention, and only if in the third country there is a technical solution to dispose properly the waste. Now, what we know about viral, that was where the technical solution we assessed for the final disposal. But something that we know is that the viral load present many viral load waste present main constraint. It's a liquid waste, which make it so difficult to handle due to spillage. It's difficult to storing, huge volume, transport. It's not easy, and finally, all this can compromise the safety. It's big volume. It means storage capacity can be an issue, transport can be an issue, and can be expensive. And there is no calorific value. It means that it's not interesting for cement factory, and in case of an incinerator, it increases fuel consumption. So what we try is absorption. We tried several material, like a sort of absorbent pad, diaper, and finally, we decide to go for the charcoal. Well, okay. I want to show you this video. You can see 2 ounces of water in a cup of biochar and charcoal. And I mean, the charcoal is moist, but no water, unabsorbed, and more water could be added. That means that biochar charcoal can easily absorb 25% by volume of water. What's the added value? Why absorption with charcoal? Because it's first, the choice is because it's available everywhere and it's quite cheap. It turns liquid waste into a solid waste. The volume is reduced and it increases the calorific value. It's a very important point because it makes the viral load waste destruction more interesting for cement factory because it will be fuel for them and reduce the consumption for the incinerators. Additionally, making the liquid waste a solid waste makes the handling, the storaging much easier and safer. Here I want to present to you shortly the logic frame, all the different steps we went through before assessing a different solution. First, the first question was if there was a national regulation available. And yeah, if there is a national regulation available, we go on the left, and we have two options then. One, if it's possible, outsourcing option available for transport, storage, and final disposal. Imagine a private company that can take care of the storaging, transport, and the final disposal. Or if it's not possible. If it's not possible, it will be our responsibility to identify the best final disposal solution. But what happens if a national regulation is not available, or like Mozambique, for instance, was not implemented? But first, we need to identify if there is no national regulation. We need to identify the most suitable and most updated regulation. Why most suitable? Because that depends which kind of country. I know, for instance, that Southern African countries are trying to standardize some regulations. So that's why in Mozambique, we decided to implement the South African one. Once we agree on that, we need to assess the final disposal solution available in the country. I know it sounds strange to start from the final solution, the final disposal solution, but because this point will affect all the others. Once we identify the final disposal solution available locally, we can then define the storage, how to store on a long and a short term our waste. Which kind of packaging? If we have to go to a cement, if the final disposal solution is a cement factory, we will pack in a way. And if it's an incinerator in a big hospital, we might have to pack our waste in another way. How to transport? Maybe we will have to transport the waste from the warehouse to the cement factory or not, if the incinerator is installed in the same place of the labs. We will have to define standard operation procedures for everything, handling, transport, and important personal protective equipment for each one of those steps. And then, in collaboration with other actors that we will see later, we have to define certification and collaboration. Who will certify that the waste has been properly transported? Who can certify that the waste has been properly disposed or packed? Who will certify all this point? That's why we are talking now about a multidisciplinary approach. It's not just the lab itself or the Ministry of Health. There are many different actors with different skills that need to be involved in this process. For instance, the Ministry of Health, because in Mozambique, Ministry of Health was the one responsible to produce regulation and law. The Minister of Environment, because it was responsible to produce, to certify the transport company and the cement factory, and the Minister of Transport, because it was in charge for transport safety. When we talk about outsourcing option available, we need to assess public service. Maybe they are available. They are part of Minister of Health or Minister of Environment, but as well private sector. That might be private company that are providing this kind of service. When we talk about most suitable and most up-to-date regulation, it's not something we can decide on our own. We need to be involved the Ministry of Health that have to approve this choice, the Minister of Environment, and the Minister of Transport. Then each one of the steps involves different actors. Packaging, it might be the Minister of Transport and the Ministry of Health. Transport, again, is the Minister of Environment and Minister of Transport. Storage, same, environment and transport. SOP and PP, it depends which kind of, are we talking about PP for transport? It may be the Ministry of Environment or Ministry of Health, and certification and collaboration, all of them. That's why it's really important to have all the different actors around the table. It means having technical know-how, medical background, and legal framework understanding, advocacy, all together, for instance, to convince the cement factory to accept this challenge, why the cement factories should accept to burn medical waste, if not for advocacy purpose. So it's really important to have a multidisciplinary approach with all the different actors, stakeholders, specialists, technical specialists, people with medical background, lab technician, all around the table to go through this process and make it more sustainable and efficient. Voila. Many thanks. That's it.
Thank you very much, Luca, for the presentation. And we still have enough time, I think, for some question and answer segments. So without wasting much time, I think I'll turn it over to Nicholas to take the questions that have been coming. If you do have questions, please put them in the chat box and we will take them as they come. Nicholas, are you ready?
Okay. Yeah, okay. Thank you very much, Anafi. There are a couple of questions in the chat box, but some members have requested that they want to hear the perspective of the manufacturers at the end of the presentation. Since we have some members who are online, I've checked through the chat box and I've seen colleagues from Cepheid and Abbott. I don't know whether they could be interested in saying something about what they are doing in waste management. For example, Martin Koller from Cepheid, and then Pam Pile from Abbott. I don't know whether you have something to say. Colleagues have requested that you say something about waste management. Are you there?
Yes, it's Martin here.
Okay, thank you.
I wouldn't say too much at this point. This is a subject which clearly interests us very much. We understand the importance, and we're looking to two aspects of this. And we've been talking to the gentlemen from CDC who are working on this, and we'd like to see what direction this takes before doing too much, because it's pointless us doing one thing when it may not be the right thing to do. So yes, there are aspects of making the products themselves less hazardous. And the other aspect is working on networks on how we can recover the cartridges and return them to a place where they can be disposed of, because that could potentially just be reverse logistics. It's the opposite pathway that the cartridges take when we distribute them to the site. So we'd be interested in working on those transport networks as well. So that there are many things that we could get involved in, and we're very willing to get involved in. But we are, like you guys, we're looking for guidance from those people who know. And it's refreshing to see this presentation from somebody who clearly has expertise in the field.
Okay, thank you very much.
Hello, I think, Nicholas, we just want to take the opportunity and say that we appreciate the manufacturers joining us today, and we had planned to have a future session that would be specifically devoted for that purpose, since we have had so many questions during these sessions related to the manufacturers and if it's agreeable with Cepheid, with Abbott. We also have reached out to Roche. We would like to schedule a session in the fall so that our field colleagues can directly answer their questions, and we would solicit those questions in advance so that you would have them to be able to respond.
Yeah, I think that would be very useful, particularly how we can interlock with you in whatever you choose to do. For example, it would be quite possible to distribute the containers for returning waste along the same channels where we distribute the products. So I think it's really a sharing of knowledge that's required here.
Martin, that is a suggestion that we've been discussing quite frequently over at least the past week or two regarding reutilizing the transport lines that are used for supplies and basically backtracking for waste. And so I think that that's a fantastic idea and something that needs to be explored.
Yeah, I think there was something interesting I saw earlier this week in Nepal, where they're using drones to collect samples and to send drugs to the clinics. The same channel, if it's effective, would presumably return the same cartridges in the other direction.
I think that the sustainability is something that really needs to be looked at for any of the ideas that we discussed for waste management, as well as any other sort of business strategies for doing this. Anything that makes sense, that saves money, saves time, saves effort, I think is worth exploring those options.
Okay, thank you very much. Going back to the questions in the chat box, questions directed towards the presenter. The first one is from Ndugwani, and is asking, where were you storing the chemical waste? At the facility or at national level? Where were you storing the chemical waste? I think before taking it for disposal, where were you storing it? Yes, Luca.
We were working at the beginning with only one lab that was based in Jose Macamo Hospital in Maputo. We were storing the waste in the facility itself. We had the dedicated storage facility, and that's it. We never managed to put it on a national scale, unfortunately, but I'm sure they're working, and my colleagues try in other countries afterward. But in that specific case, we were storing in the facility.
Okay. An interesting question from Maria is, how long can you store the hazardous waste? How long can you store the hazardous waste?
That's the point. Unfortunately, if we have a look at the technical safety data sheet, there are many information missing, and how long you can store the other waste, that's depend of the kind of final disposal solution you identify in your country. If you go for a cement factory and the cement factory propose you to proceed to the destruction every 6 months, you will have to store your waste for 6 months. If you have an incinerator in your hospital facility, you can dispose your waste on a daily basis, which means without any kind of storage needed.
Okay, thank you. The other question is from Edie. What is the reference for the 1% hazardous waste for the small incinerators? The extraction is based upon the composition, characteristics of the waste, then 1% of what? Liters, kilograms, what? Repeating the question, what is the reference for 1% hazardous waste for the small incinerators? The extraction is based upon composition, characteristics of the waste, 1% of what? I think it needs some little more clarification of what the 1% is made up of.
Yeah, it definitely. It's I can share the reference, something we find in the European Commission regulation for hazardous waste management for a small-scale incineration plant, and it was talking about volume over volume.
Okay, thank you very much. The other question is from Dr. Pasco, and she's asking, would international regulation be okay if there are no national regulations? Would international regulation be okay if there is a country with no national regulation?
Definitely, if there is no national regulation, we should always go for international and more updated one. But as in one of the last slide, I said that we need the agreement. We need a different authority, different actors to be involved in this decision, like a Minister of Health, Minister of Environment, and the Minister of Transport. So yes, we can propose to use the international regulation, but need to be accepted and validated by the different actors and stakeholders involved.
Okay, thank you. If you're not speaking, you mute yourself. Yeah, I think on that note, I don't know whether Luca, you can share any document with the international regulation with the community, so that we may look through as even country teams seek to do their national regulations. Yeah. I don't know whether you can share such a document with the community.
Yeah, there are documents that are driving putting a direction to the national regulation. I can prepare a folder and can be shared by David or Anafi, if that is okay.
Great.
Okay, thank you very much. The other question from Kareni is actually an interesting question. Is the use of charcoal environmentally friendly? Is the use of charcoal environmentally friendly?
The use of charcoal is firstly, as I said, to turn the liquid waste into a solid waste to make it safer for handling and storage. And then because it increases the calorific value. So if we add the charcoal, it will reduce the need of fuel for the cement factory and the incinerator. Without charcoal, the incinerator will consume more fuel. Listen, I would say the impact of, I'm not sure if it's really environmental friendly, but the difference is probably really limited because with charcoal, the incinerator and the cement factory will consume more fuel to burn the waste, while with charcoal, they will consume less. And again, this is on top of the calorific value is to reduce the risk in handling and storaging. So yeah, I cannot tell if it's environmental friendly, but it's better for the safety.
Okay, thank you very much. I think Pam Pile is putting up her hand. Pam, I think, wants to say something before we continue with the questions. Pam Pile, you want to say something? Yes. Okay.
Thanks very much, Anafi. I know there was a request for comments from the manufacturers. So I'm from Abbott's and responsible for the rapid diagnostics division and marketing for HIV. So the MPMA platform is the product that I would like to just put a comment on since the request has come forward. The MPMA viral load and detect cartridges for viral load and EID do not contain GTC. So, you know, I'm very much interested in the waste management issue, but I guess from a different angle. One, to ensure that, you know, the LabCop community is aware of which technologies have which types of waste or chemical compounds. And I can share the SDS files should that be required. And then also to say that we do recognize that, you know, there is other waste that our, you know, that our cartridges do create in terms of standard biohazardous waste. And we do recognize that, you know, as countries think about scaling up of points of care platforms and the cartridges that those would produce then and the waste that would produce,
Okay, thank you very much. Thank you very much for that. The other question is from Fibion, and she's asking, was a cost efficiency analysis done for the different methods talked about here? Was a cost efficiency analysis done for the different methods talked about here? Yes, Luca, you are welcome to answer.
Yeah, thanks. Actually, the idea there was to try to assess the three different disposal solutions available in order to increase our know-how and try to replicate it somewhere else according to the other country availability. Although then we did a cost analysis, and it was clearly, I mean, cement factory was more cost efficient because we had internal storage facility for our waste, and the disposal price for kg for a cement factory was absolutely competitive. But again, the idea was not to identify the most cost efficient way. The idea in Mozambique for Doctor Without Border was to identify technical solution and see if they were replicable somewhere else.
Okay, thank you very much. Another interesting question from Clement. What about the added weight impact on the cost from using the charcoal to convert liquid waste to solid waste? I'm repeating the question. What about the added weight impact on the cost from using the charcoal to convert liquid to solid waste?
It's true, more weight means more kg that need to be paid, but at a lower price. Because to burn 1 liter of waste, pure waste, it can cost us, like, I'm just giving an example, 10 liters of fuel, but to burn 1 kg of charcoal with 1 liter of viral load absorbed into it will cost us 5 liters. So yes, it costs more in terms of kg to be disposed, but it reduces the cost per kg. It's a matter of negotiation with incineration or with the cement factory. And again, the idea for us to turn it was to use the charcoal was to make the viral load waste destruction interesting for the cement factory itself. And sure, to increase this, to reduce the risk.
Okay, thank you. I think.
Let me add a question. Let me add a question on this charcoal thing. Look, sounds very interesting, but probably some more practical ideas need to be shared. Were you breaking down the charcoal into dust so that you increase its absorption capacity, or you were picking the big lumps of charcoal? And how was the absorption accelerated? Where were you putting? Where was the absorption happening? Were you putting the charcoal on the ground and pouring the liquid on top of it? How was the real practical aspect of doing this happening? Because I've seen in the video, the charcoal was in the lumps, was big blocks. So yeah. Was the solution the one that eventually formed it into a big block after having absorbed when it was in dust, or it was blocks already? And you said it is 25% absorption. So when you say 25%, if I have 100 kilograms of charcoal, how much liquid waste will that take?
Okay, so what we were doing, we were just turning it into not even dust, but small diameter pieces with a riddle, and we were putting it in a plastic jerry can, 20 liter. What we were doing, we're adding by volume, half of the jerry can full of charcoal, and then we were pouring the viral load waste into it. That's to let it absorb it in a closed environment. We didn't try to just pour the waste on an open charcoal and go for evaporation as well. something we witness is that when the viral load waste, there is a splash that is not cleaned up, the viral load waste turn into a crystal, and that make probably more dangerous as well for inhalation. So we were doing it in a closed plastic jerry can. What we were doing is half volume by volume, so 10 liter of viral of charcoal and 10 liter of viral load waste. What we witnessed is that after a days, all the viral load waste was absorbed by the charcoal. This video was talking about 25% because it was about biochar that is a specific charcoal. It's not normal charcoal. So what we were doing was 50-50, volume by volume, and that it works.
Okay, and then you were burning the entire jerry can. What
Yes.
about that gas coming from the polythene, the plastic? How was that environmentally friendly?
This kind of incinerator, if I can, do you mind if I share again the presentation? 1 second. This one.
No, you can explain because we have barely 2 minutes to go.
Okay, sorry. Just I want to share you this information. This kind of incinerator have specific emission data that are granted by the manufacturer. Total dust, sulfur dioxide. They have a filter, and it's absolutely the same for a cement factory. They have a filter that's allowed to absorb all the rest that are not decomposed by the thermal decomposition.
Okay, thank you very much. I think we are time bad. We have barely 2 minutes to go, but I think this has been very insightful. And I know there are still quite a number of questions that only time has limited us to have them exhaustively answered. But let the discussion continue on the WhatsApp platform. Let the questions continue being pushed, and let the responsible people continue answering the questions. So Nicholas, who has been monitoring our chat, you'll have to list the questions and I think push them onto the WhatsApp group. Maybe give them to the presenter and then push the answers on the WhatsApp group so that the questions get answered. Otherwise, I want to thank the presenter. Practical solutions speak for themselves. If it's not hypothetical, it's not a theory, but something somebody has done and that it has made a difference. It speaks a lot of volumes. So thank you very much for sharing that experience. I know there are still questions, but they should continue to be answered through other platforms that we have to continue the discussion. Otherwise, within the next few minutes, I'm seeing Anafi, you wanted to say something? I saw your hand.
Oh, sorry. I think I was trying to switch off something. But just to, yeah.
Okay.
Thank
fine.
you. Just to maybe since you have, yeah.
Yeah.
Okay,
you can say if you want. You have something to say quickly.
Oh yeah, just to say, I think thanks a lot to Luca for the presentation, and to just say, I think we learned a lot today. Like Charles has mentioned, I think just to summarize the key conclusions that we are actually getting here, that in as much as we are looking at chemical waste, I think all hazardous waste just needs to be disposed safely, whatever the context. And he mentioned things like relevant conventions that are coming in. And this is just to raise our attention within our countries that we need to think of conventions, not only waste around. And then there are quite a number of those solutions that are existing. And the fact that we also have manufacturers, authorities, and implementers all in one table like today, it means that although the waste generator just stays responsible, that is, I think, us who are producing the waste, efforts and the authorities of manufacturers and everyone required here is required here to make this a success. So thanks, Charles.
Okay. So we will be sending out the invite for our usual eco session for this month. You'll be getting the invite this week, which will happen on the 28th of this month. And this time around, we are having a very interesting presenter who is a peer educator and part of the civil society, who is going to share a very inspiring experience and is a great advocate of viral load, stroke, drug resistance. So is going to be the one sharing for the next session. So those of us, please make it a point you are on that eco session of this month, which is coming in on the 28th of June. Otherwise, we've been telling you to let us know, those of you who are going to be in Mexico, so that we have an idea of how many of the members that are going to be there, so that we can see whether it's viable for us to plan a meeting, a side meeting for the community to update and also have a light moment of sharing together. With that, we continue to remind you to continue leave no stone unturned around your action plans until when the implementation begins. As the time for planning is still on, make sure you leave no stone unturned. All your plans, for them to be implemented, they need funding. And any funding window that is there, we should optimize the moment. Please continue pushing the stakeholders to ensure that your needs are ably considered. Thank you very much. We are already 3 minutes above our usual time. We thank you all, and especially to our presenter for that insightful discussion. Thank you.
Many thanks,
a nice day. Thank you. Nice evening. Bye. Bye-bye.
Thank you. Bye-bye.